Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at Parallelogram Law of Vectors. In our previous video, we spoke about the Triangle Law of Vectors and how it's applied on some basic things you need to know when dealing with Triangle Law of Vectors. Before we continue with the Parallelogram Law of Vectors today, I would love to stress or chip in something again from the Triangle Law of Vectors. So we said when two vectors acting at a point are represented by both magnitude and direction, the third um such that they are in the same order. So such that they are in the same order. So this same order shows like starting from here to here, then let's say this is the first vector A and this is vector B. So vector A starts and ends here. Then the second vector, that's vector B, now starts from where vector A ends at and come here. So when two vectors acting at a point are represented by both magnitude and direction such that they are in the same order, the resultant vector is the third side that completes it. The third side of the triangle that completes it, such that the three vectors are what are in equilibrium, and you know that the resultant vector is also represented by both magnitude and direction. And now to identify the resultant vector with this, it has two arrows just to distinguish it from the normal vector. So the resultant vector has two arrows and it starts from the tail of the first vector and ends at the mouth of the second vector. Yes, and that's one thing you need to know about the triangle law of vectors. Now, coming to parallelogram law of vectors, we see that for triangle law of vectors, the two vectors are either they are in the same order, they are inclined. So they are in the same order. They are moving from here to here. It's like the two vectors are in the same order. But in parallelogram law of vectors, it won't be seen like that, but rather the parallelogram law of vectors is so for parallelogram law of vectors, the two vectors are either, let's say this is vector A, this B, they are either coming towards a common point, that's this, or moving away from the point. That's one difference between the triangle law of vectors and parallelogram law of vectors. In the parallelogram law of vectors, let's state it using a diagram. So it says that when two vectors acting at a point, so this vector A acting at a point, are represented in magnitude and direction by the adjacent sides of the parallelogram, the resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the point. My diagonal doesn't fit this, so let me just draw one to fit. It's also a point. So yes, let's just take it like this. So when two vectors represented in magnitude and direction, when two vectors acting at a point represented in magnitude and direction by the adjacent sides of the parallelogram, the resultant vector is represented in magnitude and direction by the diagonal. So this is the diagonal. By the diagonal of the parallelogram drawn from the point. So in this case, we can see that this vector A has a similar one here, same one here, and this vector B also has one here. So we see that from this point, the two vectors are moving away from the point, but from this point, they are coming towards the point. So now you can see that resultant vector can be calculated using the cosine rule, because over here we have a triangle forming in this parallelogram. We have two triangles forming in this parallelogram. So the cosine rule, just as used in the triangle law of vectors, can be used over here to find the resultant vector. So there are some things, or there are some criteria or eligibilities when using that must be qualified before using the parallelogram law of vectors. So the first one is these two vectors A and B must be inclined at an angle first. And secondly, these two vectors must be what the direction of the two vectors is in such a way that they are either coming towards the same point, both of them are either coming towards the same point or moving away from that point. And the third one too is that the parallelogram is drawn from these two vectors. The two vectors that is seen here generated this whole parallelogram. So yes, a parallelogram is drawn from these two vectors. And then also the last one is the diagonal of the parallelogram is drawn from the point where the two vectors meet, or where the two vectors diverge from. And when after drawing that, you see that yes, there is a triangle. It has two triangles, which is the C. I allocated it as C for this part and this as D. Now, yes, from that then we can see that the cosine rule can be used to find what this side, which is the diagonal. So can be used to find the diagonal, which is the resultant vector of this. So that's how we use parallelogram law when adding vectors that are inclined. Thank you for watching this video, and I hope to see you in our other videos.